Okay, today we're going to do section 1-4, integers and absolute value. Let's go ahead and number the bottom of your page, page 1. And we'll start with comparing and ordering integers. First of all, a negative number is a number that is less than 0. Negative numbers, positive numbers, and 0 are members of the set of numbers that we call integers. Let's look at the number line. Let's go ahead and write our numbers in. So we'll write 0 in the middle, 1, 2, 3, 4, 5. And on the other side, negative 1, negative 2, negative 3, negative 4, and negative 5. So if we look at our number line, all of our numbers that go to the right of 0 are going to be our positive integers. And all of numbers that go left of 0 are going to be our negative integers. And that leaves us in the middle with 0. And 0 is neither negative nor positive. So if we write the set of integers, it can be written like this. We're going to have dot, 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 because those 3 dots show us that it goes forever and ever to the left, or to the negative numbers, infinity. Then negative 3, negative 2, negative 1, 0, 1, 2, 3, and we'll 3 dots again to show that we go all the way to the right in positive infinity. Let's look at some examples with negative and positive numbers. First of all, if we're going to write integers for real-world situations, if we set a loss of 25 yards, we would write that negative, because if you lose 25 yards, you're going to have a negative number. Number 2, a temperature at 10 degrees below 0 would be written as negative 10. Or you could write it as negative 10 degrees. Number 3, if you deposit $30 in your checking account, that's going to be a positive number. You can write it with the dollar sign or without. Generally, when I do word problems, I leave off the labels with dollar signs and those sorts of things. Number 4 is something from golf. If you are 2 over par, they consider 0 to be even. So 2 over par means that you are positive 2. And number 5, if you withdraw $100 from your savings account, then you take 100 out, so we're going to have negative 100. All right, let's turn to the next page in your notes. And down at the bottom of that page, let's go ahead and number that page, number 2. And I want you to pause the video for just a couple of minutes and do the practice problems at the top of the page. When you're finished, go ahead and continue the video. Okay, hopefully you've completed the practice problems at the top of this page. And now we're going to talk about comparing integers. To graph integers, we locate the points named by the integers on a number line. So if I wanted to go ahead and fill this in as 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, and negative 5 on my number line. And if I have a dot located at the negative 4 and the positive 2, then this point would be the graph of negative 4, and this point would be the graph of positive 2. We need to also remember what the symbols mean when we're talking about comparing. So the symbol below is less than, so less than symbol means less than. And the symbol below that is the greater than symbol, so it means greater than. Any mathematical sentence containing less than or greater than is called an inequality. And we'll be talking a lot about inequalities this year. We'll do some simple ones like today, and then we'll start doing some more difficult ones later on. An inequality compares numbers or quantities. So let's take a look at our number line. Once again, we'll just go ahead and label it. And once we label it, we're going to mark some points on here. We'll mark a point here at -5, here at -3, here at -1, one here at 4, and then we're going to look at the two statements below. Number 1 says, write two inequalities involving -3 and 4. So if I look at -3 and +4, and I want to write two inequalities involving those numbers, I could say that -3 is less than 4, because it's a number that is further to the left, or I could say that 4 is greater than -3. So that's two different ways to say the same thing. Notice that the arrow in your symbol, in your inequality symbol, always points to the smallest number. And the opening is going to point to the greatest number. Number 2 then, -5 and -1, and we want to compare them with symbols. Well, -5 is less than -1, because if you look at the number line, -5 is further to the left on the number line than -1. All right, let's look at the next page of your notes. Down at the bottom, let's go ahead and number that page 3. And we're going to order integers from least to greatest. So if you need a number line to do this, you can make yourself a number line on another sheet of paper and then come back to the video. Just keep in mind that the further to the left on the number line, the smaller the number. So if I'm going to order these numbers, I'm going to look for the one that's going to be furthest to the left, and this -20 is going to be the furthest to the left. And then -15, and then -5, because I know all my negative numbers are going to be smaller than my positives, and then 0, 2, and 3. And that shows that the numbers are from least, -20, to greatest, +3. In number 2, we have -14, -5, -2, and -8. So they're all negative numbers. We're going to look for the one that's going to be furthest to the left. In this case, it will be -14, then -8, then -5, then -2. And you do need to use your brackets around these, and yours may be not very pretty. Sometimes mine aren't either, and that's okay. The next concept we're going to look at is absolute value. Now, you may have already talked about absolute value at some point in one of your math classes, but absolute value is of a number is the distance the number is from 0 on a number line. The absolute value of a number is always greater than or equal to 0. So the actual absolute value of a number is never going to be negative. Let's take a look at the number line. And we'll go ahead and fill it in with some numbers. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, and -5. If we want to know what the absolute value of 4 is, we're going to first write it in absolute value symbols, and those symbols are 2 bars on the either side of the number, and that's read as the absolute value of 4. So what we'll do is we'll look from 0 to 4, and if I count from 0 to 4, I have 1, 2, 3, 4 units. So the absolute value of +4 is 4. Now let's look at the absolute value of -4. Once again, we'll write it in the absolute value symbols, and we'll find out how many units it is from -4 to 0, and we'll count 1, 2, 3, 4. So from -4 to 0 is also 4 units. So the absolute value of +4 is 4, and the absolute value of -4 is 4. All right, down at the bottom, let's look for some examples. Expressions with absolute value. We're going to evaluate each expression. The absolute value of -6 is going to be 6 because it's 6 units from 0. Number 2 says the absolute value of 3 plus the absolute value of -7. Well, we know that the absolute value of 3 is 3, and the absolute value of -7 is +7. So we want to find the absolute value first and then add them. So 3 plus 7 is 10. In number 3, the absolute value of -5 minus the absolute value of 3. So the absolute value of -5 is +5, minus the absolute value of 3 is 3, and 5 minus 3 is 2. Okay, let's look at your last page of notes. And at the bottom, you can number that number 4. Algebraic expressions with absolute value. Now, we've already done some algebraic expressions and substitution, and this will be no different, other than we're going to have absolute value involved as well. We're going to evaluate each expression if A equals 0, B equals 3, and C equals -6. So we have 14 plus the absolute value of B. And up here it tells us that B is 3, so we'll write that in the absolute value symbols, and then we'll evaluate. 14 plus the absolute value of 3 is 3, and 14 plus 3 is 17. In number 2, we have the absolute value of C minus A. C is -6, so we'll write that in absolute value symbols. Minus A is 0. And we'll evaluate. The absolute value of -6 is +6, minus 0 equals 6. In number 3, we have the absolute value of AB plus B. So we'll do the absolute value of A is 0 times the absolute value of B, which is 3. So we'll go ahead and put that in absolute value symbols, plus B, which is 3. Now we need to do what's inside these symbols. So 0 times 3 is going to be the absolute value of 0 plus +3. The absolute value of 0 is 0 because 0 is 0 units from 0, and 0 plus 3 equals 3. Okay, bring these notes to class with you tomorrow, and we'll go through them, answer any questions you have. I would suggest looking back over the notes. If there are any questions that you have, write them down. We'll talk about them, and then we'll do the homework in class.